Hi. Dean and Gavin and Lainey and Ryan, whoever checks out this video, hello and welcome. Everybody else has been working on 2018 number 5. 2018 number 5. They were working on this FRQ and we were building up to part D, and part D needed L'Hôpital's. Because trying to pursue the limit right away as is written will produce an indeterminate form. But first, let's go ahead and grade A, B, and C. Why not, right? We were reviewing all kinds of stuff. And let's see how you guys did in A, B, and C first. D is the one where it's like, look at the answer key. You think you might have it, and then they would have taken off points, and it's tricky. Dean, I'm putting a handout back for you on your computer. Gavin, there are extras in the front tray. Ryan and Lainey, same for you guys. On top of the front tray. Okay. There we go. So, let's go check out the answer key for number 5, A, B, and C, and then let's talk about part D. Ready, set, go. Part A was 1 point for getting the correct answer. If you made any sort of mistake or error in your notation, in your wording, in your plugging in, you'd have some issues. If you stopped at F of, that is not sufficient. You had to plug in, but you did not have to simplify. If there was any simplifying, was there? I guess pi minus 0. But anyway, you can give yourself a check mark if you got all that. Now, technically, did they say on number 5 that you have to explain in context of the problem? No, it just said find the average rate of change, so you probably did not have to include this wording. But you did have to include this part for sure. Boop. Letter B. Now some of you are like, I just went straight here. That's dangerous. You should show that you know what you're plugging into. You should show the average rate of change formula and then plug in. Any questions on part A? Part B. Part B. You were trying to find the slope of the line tangent, aka the derivative, using a product rule, because it was by hand, right? And then plug and chug. You know what's snazzy? I learned at the workshop that I went to this year that you do not have to evaluate any trigonometric expression on an FRQ. Which means if you're iffy on your unit circle, stop and box and be done. I double and triple and quadruple checked. I have heard multiple things over the years. But I was with quite the seasoned bunch of AP teachers along with ones that have been readers on AP exams before. You do not. You have to have a numerical expression, but you do not have to have actually plugged in the trig. Oh, that's nice. Oh, it's kind of nice. Yeah, you could have just left it sine of 3 pi over 2 and cosine of 3 pi over 2 and been done, 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 done. Pretty snazzy. And then they just used the words, but once again, I don't think they said to explain, so I think the answer was sufficient. You did not have to get it all the way down to that. So did you take the derivative appropriately? Number 1. Oh, guys, show taking the derivative. Don't go straight to plugging in. Show your work. Then plug in and then stick it to the man. Please, please, please. Letter C. Oh, I think they're trying to find an absolute extrema. How do I know that right away? I see the word candidates and I see a table. And anytime there are candidates and a table, they are testing the critical numbers and the endpoints, which are the legal candidates. Now, here's the hard part. A few of you in the past, whether by means or whether because of a sign chart or because of a given graph of a derivative, have ignored and not chosen to test any relative maximums when looking for absolute minimums, because you're like, if it's a max, it shouldn't be tested, right? The problem is, wrong. They would take off a point for you not having tested all the candidates. Meaning, test all of the critical numbers with all of the endpoints, regardless of whether or not you know the relative nature of any of the critical numbers. Does that make sense? Sad, but true. Yes, the AP teachers groaned on that one too. We were quite distraught. We're like, they knew it was a max. Why would they need to test it? Anyway, long story short, test all of the critical numbers with all of the endpoints. Did you have to make them all nice and neat and simple? Not necessarily, but you did have to compare which one was higher or which one was lower. If you plugged in and wrote an incorrect solution and got the right answer, you would get the answer with justification, hopefully. But you might have missed, well, actually, you would have probably missed the answer with the justification. If you had written an incorrect expression when plugging in, then you might have gotten this point taken away, or you would have gotten some point taken away. I'm guessing it would have been this third one. So be careful. You don't have to get it simplified, but you do have to compare who's higher, who's lower. Long story short, is this gross? Do you have to compare e to the powers to know who's higher or lower? Well, he was a negative number. That kind of helps, but still. Looking for the minimum. I guess he's positive. Oh, I guess it wasn't that bad. I didn't realize he was the only negative. But long story short, remember, you do not have to simplify. You could have this with the sines and the cosines and all that jazz. No. Did the original expression have sines or cosines? Oh, it did. Yeah, you could have left it with the trig. You didn't have to simplify, but you did have to say where it was, and you did have to have testing of critical numbers and endpoints, and you had to show you're solving for the critical numbers. I'm not making this stuff up. You had to show solving for the critical numbers. Look, you had to show, not all the, like, you didn't have to draw a unit circle, come on, but you'd have to show, oh, hey, critical numbers, I knew what to do and where to find them. And then you plugged it in with the endpoints, and then you did the answer justification. Yeah.
So for me, I put I just wrote e to the x and then parentheses cosine x minus sine of x, but I didn't put equals 0.
You technically would have missed number 1. Because where did your pi over 4 and 5 pi over 4 come from? They're not saying that you, well, I'm not saying that you didn't know how to do it. I'm just saying your work wasn't sufficient. So then set equal to 0, find your critical numbers, and be like, hey, here are my candidates, here are my endpoints and my critical numbers. Okay. Letter D. Letter D. Does their work look different than yours? Almost definitely. What did they do and how did they do it? Did they take the limit of the top? Yes. Why? Because that's how you take a limit of a fraction. You take the limit of the top, technically, and the limit of the bottom, and you put them together. What's awkward is that we never show that work if it's not indeterminate. If it's not indeterminate, we just plug in and have an answer, and we're done. No big deal. If it's indeterminate, all of a sudden we have some issues. Because first of all, you cannot put this guy equals 0 over 0 because 0 over 0 is undefined. We can't put equals undefined 1 second and then equals an answer the next second. That would get you into a whole bunch of trouble, which is why last year we stopped writing equals 0 over 0 whenever talking about indeterminate. We instead used arrows to show approaching. But you guys can check there are 3 different points available in this one. On 2017, there were 2 different points available. We're going to go look at that handout in just a second and see if you fully understand where all of this comes, or how all of this comes. Their maximum of 1 out of 3, if you did not write a limit either with this or with this, the maximum you could have gotten is 1 right, and that's only if you talked about how G is continuous. And the limits equal 0. They're saying you don't get either of these points if you didn't write the limit notation on this and this. Oh, struggle. But they're also saying that you should have shown that G is continuous. Now here's the struggle. In the problem, didn't it say that G was differentiable? What should every good calculus student from that statement have automatically known? It's continuous. But the AP graders took off the point if you didn't state it. Yes, AP teachers got mad, but it's true. Because they're saying that differentiable clue was given so that you would connect that it was continuous. And as a result of it being continuous, you can take the limit in this nature. Now here's where a lot of messy things get introduced. Number 1, why was it so important to state continuous? And number 2, why are they writing these parts separately? Okay. Looking at 2017, the example that you guys have. Now, here, do you want to see what one kid wrote down for this answer and how they got full credit on D? You ready? The top score, not top score as in, but this FRQ, they used him as a top example. Check it. This is what a kid wrote. Note, the limit as x approaches of G is 0 since G is differentiable and thus continuous. A kid wrote this. And G of pi over 2 is 0. Also, f of pi over 2 blah, 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 is 0. And f is continuous. He's saying I need this continuous clue to be able to take the limits piece by piece of this fraction. And then he's not even using the word indeterminate. He's just saying I have a 0 for the top and a 0 for the bottom. Now I can use L'Hopital's. Okay, the new spelling is hospitals, but either way, they won't take off points for that. By L'Hopital's, the limit of the quotient is the limit of the quotient of derivatives is plug and chug, and then he simplified it. He should have stopped there. But either way. Okay, a kid wrote this. He got full points. Yours would not have looked like that, I can almost guarantee. So we're trying to fix that this year. Does that make sense? Okay, so here's what I was looking up. I have Wolfram Alpha right here. I have, I think this one is the UC Davis math site that does a lot of calculus notes. And then I have also Paul's online notes, which might not mean much to you, but he is a calculus teacher who does a great job of putting all of his stuff online and does a great job of explaining it. I just have different variations of what they explain L'Hopital's rule to be. Now, these are not necessarily AP guys, per se. But these are actually like more technical and not just going for the AP. So if you guys are looking at this one, for instance, we say something to the effect of, suppose that the limit of f and the limit of g are both 0 or both infinity, or negative infinity. And then they basically say that L'Hopital's can or should be applied, and they talk about how it was in his math textbook, but really he got it from Bernoulli. Anyway, all this stuff. This guy, the UC Davis site. Ready? Theorem number 1. Suppose that the limit as I go to whatever of f is 0, and suppose that the limit of g is 0, and that both are differentiable. Now, careful, and thus continuous. And the functions are differentiable on the open interval containing a. That's part of the wording in our forever card. And then it also says g prime is not 0. Okay, it gives a little more information. This is nothing that I've seen the AP actually test you on before or expect you to write. But then I can apply L'Hopital's rule. Now they do a few different qualifications having to do with indeterminate form. And they have a separate theorem saying, hey, it's also true if the limits are both infinities. And they give 0 over 0 in quotation marks. Infinity in quotation marks. UC Davis with their math system, they're saying, okay, yeah, we get it. 0 over 0 and infinity over infinity. Don't confuse L'Hopital's with the quotient rule. It's good. Check it. Look, look, look. They're putting... But will the AP guys take this? No. Because this is saying equals an undefined answer, which is not true because the limit a second later is 1/4. So this is what we cannot write. We cannot show 0 over 0. Look at their own theorems. Their own theorems say limit of the top is 0, limit of the bottom is 0. We're allowed to do that for a fraction if they're both differentiable and thus continuous. It's going back to limit properties. It's messy. But then even the college professors understand these shortcut notations, which is what we've been using. Just the AP guys do not approve of it because they're trying to make sure that your answer is completely seamless, perfect. Which means not writing equals 0 over 0. Okay, and then this last one, Paul's. He does, 0 over 0. Get it? Infinity over infinity. This guy's also a college prof. So this is not something, like, this is accepted in the mathematical community as far as teaching Calculus 1, Calculus AB, I don't even know what you want to call it, math, whatever, 401. It is acceptable outside the EP. The AP is just not acceptable inside the AP. And I think he went on to actually define L'Hopital similarly to the rest. Oh no, he just uses words to explain it. Yeah, he uses words to explain it. So once again, this is not acceptable for us. So I wanted to show you guys, like, first of all, it's not that we're doing stupid stuff when we're doing 0 over 0, infinity over infinity. It is a proper shortcut anywhere but the AP. So coming back with the AP, it's much better to think about L'Hopital's in this form. Suppose that the limits of the top and the limits of the bottom are both 0 or both infinity. Or you could show them separately. Let's go back to what you guys are seeing as far as your 2017. Hold on. This kid. Check it. Check it. This kid, did he do good math? Yes, he got the right answer. And he showed L'Hopital's. Let's see how many points the second one got. It's the second one, right? The third one, oof, I don't know what the third one's doing. The third one had some issues. He was kind of going the right direction, but he didn't even show the derivatives, and he did some sort of awkward no derivatives there, and I'm not sure what was going on with the third one. But the second one, sample A, got a 6 because he got the second point because he wrote that. He got the third point because he got that, but he missed the first point because he didn't talk about the limit of f and the limit of g being 0, and he didn't talk about g being continuous. Either one of those not being present would have lost him the third point. And then that poor last guy, did he get anything on L'Hopital's? It was a no. It was a no on the third point. It was the max of, oh, nope, he didn't miss any though. Or, sorry, he didn't get any. Because he didn't talk about g being continuous or equaling 0, and then he didn't show a limit attached to derivatives, and then if he didn't have limit notation, he couldn't have gotten the answer even though he wrote it correctly somewhere on the paper. Okay, bleh. So let's go back to your guys's. It was a different FRQ. It was a different year. P.S. It's been on 2017 and 18 and 19 for A, B, B, C. I'd have to look at, I think number 6, which was 2017, was a shared FRQ. Number 5 might not have been, but it's typically on A, B, and B, C. For you guys, oh, did I just lose the answer key? No, I just lost the answer key. I'm so sorry. Calc AB FRQ scoring. There we go. How many points did you get on it? Nope, that's the same one I just did. Okay. Why am I making a point on this? Just because, guys, I would love if you would help me rewrite the forever card to be appropriate to what kids need to be showing on the AP, both for you and for the AB kids, and for you to know fully what to show or not show when solving these. So what notation or what work do you see them showing? They separated the f and g. They showed a 0 over 0. They could have also said something like the limit as x approaches pi over 2 of both, with words of both f and g are 0. They could have used that, both 0. That was terminology, not necessarily from an AP teacher, but from a theorem that's properly stated. So since the limits of f and of g are both 0, wait a minute, but we were only allowed to say that this limit is 0 because g is continuous. If g was not continuous, that would be illegal for us to actually even use. Wait a minute, why aren't they making us state that for f? Oh, I missed it. Guys, who's f in your question? What's the domain of e to the x cosine of x? All real numbers, right? And isn't it continuous for all real numbers also? He's a function that you can look at and you can see. They're not making you talk about a function who's naturally continuous, whose domain is naturally all real numbers. Who are they making you actually give conditions for? The actual g, who you don't have. You only have the derivative of g, so they're making sure that you are connecting all the dots. So looking at g prime, right? G prime. Does g prime exist at pi over 2? Does g double prime exist? No, it's a sharp point, but g prime does exist. Since g prime exists, then you can say that g is differentiable. Then you can say that g is continuous. They need you to show that you understood the clues that they gave you. So g prime exists, hence g is differentiable, hence g is continuous, hence I'm allowed to say this is true. And since I can say that this is true, that the limit is the value, that's more specifically what you're saying. Not that you can find the limit, but that the limit itself is the value. Because if the limit, if g was not continuous, you have no guarantees that this is true. Okay. Then you can say, since they're both 0, now I can use L'Hopital's. L'Hopital's states you need to be able to show, or you need to show this quotient with a limit if you show it, and the limit of the derivatives, and then you can go ahead and plug it in. Okay? If you didn't put limit, I can almost guarantee you didn't put g as continuous, so you got 0 out of 3. if you showed some version of 0 over 0 not using an equals, and you show this bottom, you would have gotten 2 out of 3 because you wouldn't have stated that G is continuous. If you had put equals 0 over 0, I think you still would have only missed that first point, and you might have still gotten both points 2 and 3. But anyway, just all things to consider. In the back of your handout, you guys actually have different sample answers that kids gave and how many points they scored. If you're curious, there's some more notes on what was accurate and what was not, etc. as far as 2017. They showed you like specifically where linkage or notational errors, you guys can Google that if you want more information, but where that stuff would have come off. But they also showed you like sample responses of kids. Now there are 2 different points to get, and so on the next page you can see like, oh, this kid got both points. This kid only got the second, only the second, none at all, only the second, only the first, none at all. So both 7 and 4. Oh, 7 was way off anyway. And what was the final answer for 2017? Oh no, 15 pi over 4. Woo! This kid had the right answer and he got no points. He has absolutely no limit drawn, and he has absolutely no, like, L'Hopital's can be applied because of 0 over 0, and he didn't talk at all about the continuity and thus the differentiability. Oh, this guy you don't have to justify, though. Never mind. Yeah. Where would he have lost it? He would have lost it by not writing the limits, because if you guys saw a second ago, they didn't write it out in 2017, but they did in 2018. If you didn't write the limit notation, that negated your points, except for stating G is continuous, but this one didn't even give a point for that, so you couldn't have gotten that either. Yeah, nasty though, right? Like you got the right answer, but you didn't get it from a limit. And so, well, here's a better way of saying it, John. For the answer, according to this kid, they said that this equaled that, but they didn't show that it answered the question of the limit. Because this is just the derivative over the derivative plugged in. It's not the limit as, so it doesn't connect the answer to the problem at all. I think that's where they lost it. All right, guys, we've done a lot of like technical, kind of like going deep into this one thing of AP graders of APs. Sorry, of L'Hopital questions. There are chief reader notes on every exam, meaning the guy who's in charge of all of the grading and of all of the judgment calls, et cetera, and of training each of the room leaders of each of the questions, of each of the exams, blah, 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 for calculus, AB, and BC. Every year he sends out notes about how the test went. So you guys can always read on those if you're curious. L'Hopital has definitely been a big topic the last few years as far as how they're grading it and why they're being so picky. If you guys want to find more information, I'm sure you can just talk about like AP grading, L'Hopital, you can go deep. But is there anything just kind of surface level or anything just like clarifying that you guys want to talk about before we just go practice L'Hopitals to finish today? Okay, tomorrow we're going to go ahead and grade 9.1 and 9.2 and go over questions that we have, but to that end, 9.1 was technically due this morning on sequences. 9.2, not series. 9.2 is L'Hopital. So check out what we currently have for our forever card. And let's talk about whether or not something needs to change. I kind of don't like how I'm stating the differentiability aspect. I think I can clean that up in a way that you guys realize you need to be like with MBT, testing for continuity differentiability. You need to be testing for differentiability. I just don't know specifically how, because technically that case where they were like, hey, the function is continuous, so the limit is, the value is 0. Such a special case. I'm not sure if I can make the forever card show that. Because I could talk about if f and g are continuous, or sorry, are differentiable and thus continuous at c, and f of c, comma, g of c are both 0 or both infinity. Like I could do that. Forgetting the whole indeterminate form, because the AP doesn't really go into the crazy indeterminates very often. ideas about rewriting from what you see?
Possibly get rid of such something. And then explaining because most is going to be 0, 0, infinity or infinity.
I'm trying to think of that.
Like limit of the expression sigma of x equals 0. And then g of x equals 0. So we're going to show the equation.
I do. I should put it both, right? Or else that's going to be iffy. I could do something like that, right? Or both 0 or both infinite.
Do you have to write the bus? Or do you still
The problem is on the FRQ, the point is that you had to state the word continuous.
you like and bus? Do you still like and continuous? Or like,
But the
You
problem
say
is then kids would be looking for differentiability and continuity.
differentiable, hence continuous.
Hence. I just saw and thus in multiple places, so I was using it. Hence continuous.
I think you could use bus like something.
Thus continuous instead of hence.
Or, I don't know.
Ergo.
Ergo.
Like word.
I mean, ergo. It's pretty nice. Which must be continuous. And which just be bond function is continuous.
Since. Guys, I realize we haven't done a lot of L'Hopital's rules, but I'm trusting that you guys are going to get stuck on ones and bring them as questions tomorrow and get a general idea, right, from last year? Your AD notes. Use therefore is a strong word. We don't have a limit as
So.
I can say if f of c and g of c are both 0 plus or minus infinity, then do you guys see any technical issues with what I have written? I'll probably put like a note about watch out for indeterminate forms. I'll keep pondering, but I think that's a better way of putting it. Well, because I could rewrite AB, I mean, not rewrite, but we could like add a little bit onto ABs maybe. Just because I need it for AB and BC.
I don't get what except for the original one.
Because it's using the limit properties. You guys can leave whenever. Sorry, you're not bound. If you guys are good, just go play with Lofi Tiles tonight. Because their point. I think Lorenzo, the way that they're going to pretty much always test this one is that you're allowed to do this. If this is true, and so then we're able to test for C over G is 3. But this breaks down as soon as C and G is 0 or D. So what they're trying to show in, I think, all of those FRQs is either with a graph or a table or like a statement of the clue, like in the one that G of pi over 2 is 0. They're trying to have you attach, can I use this to be this as that continuous differentiable thing? And then, why is it not working? And then I use the right? Because it's not what we tell. I mean, it is, but it's not. Yeah, I'll keep on saying. I won't make it definite yet. That is so cute. I know, I just like stop.
Time is E.
Wait, what is the
I'm also I don't know. Yeah, the cover, they're very right.
Yeah.
I kind of work in here. Oh, there's a cookie in there, Sarah. Bye, guys. Yeah. 6 to 8. Maybe like I know. Put her on it.
How much of the value decreased from that day? It's like what, 90%? 90%?
Like recording these.